Good afternoon, everyone. My name is Orna, and I will be your host today. We're really happy you were able to join us for the webinar. These are unusual times for us all, and we hope your teams and families are doing okay. This will be the fourth webinar in our series about water activity. If you've missed any of the previous three, they're available for viewing on our website at any time. Today we're going to be talking about the importance of reliable water activity testing results as key in preventing product safety failures. There's a lot of information out there touting ultra-fast water activity testing options. In our presentation today, we're going to focus on the requirements of common water activity standard methods and how they can be used to ensure reliable water activity test results. We're also going to discuss the risks of failing audits when relying on ultra-fast water activity testing options. Most of you know Neutec Group. Just a few words for those of you who don't. We're a market leader in implementation of technologies in quality control and research and development laboratories. Our goal is to help improve the laboratory workflow, increase productivity, efficiency, and consequently improve results. We do this by providing access to a broad selection of quality instrument solutions manufactured by our strategic partners. In the realm of water activity measurement, we're the North American distribution arm for Novazena Swiss, who's been a world leader in the industry and has been manufacturing equipment solutions for over 50 years. Today, you're going to hear from our senior application scientist, Dr. Brady Carter. Dr. Carter specializes in water activity and moisture sorption applications. He earned his PhD and master's degree in food engineering and crop science from Washington State University. He has over 20 years of experience in research and development and has been the instructor for water activity seminars in over 23 different countries and has provided on-site water activity training for companies worldwide. He's authored over 20 white papers on water activity, moisture sorption, isotherms, and complete moisture analysis. He has participated in hundreds of extension presentations and has given talks at numerous scientific conferences. Those of you who were able to join us for the previous webinars can testify to the wealth of knowledge that he shares. If you're interested, you can receive a copy of the presentation, so you don't need to keep up with taking notes. We plan on having some time for questions towards the end of the presentations. If you have questions during the presentations, just click on the chat icon and share them with us. At the end of the presentation, we're going to post a link to a short survey in the chat bar. Please take just a short moment to complete it. We really want your feedback so that we can continue to offer these webinars about the topics that you care about. On this note, I will transfer the presentation over to Brady Carter.
Thank you, Orna, and thank you everybody for joining us today for this webinar. The purpose and the objective of this webinar is to talk a little bit about the importance of the integrity and reliability of water activity testing because of the critical role that it plays in assuring product safety as well as meeting government guidelines and overall in preventing bad things from happening from processing and manufacturing products that have the potential to support microbial spoilage. And so to that end, I just want to start with just a quick overview of some different organizations that deal with compliance where water activity shows itself or is a critical part of the attempts and the efforts to try and assure safety. So in terms of government entities dealing with the safety of products, when it comes to food in the U.S., that's handled primarily under the FDA. And with with the passing of the Food Safety Modernization Act several years ago, the approach to food safety in the U.S. moved to more of a risk-based approach. And then actually the USDA is another branch that does oversight on some types of food products, some very specific products like meat and eggs. And their approach has been using a risk-based approach for some time, sort of encompassed in what's called a HACCP plan, or a hazard analysis and critical control points. And so they they have been trying to use this this risk-based approach, where you basically identify what are the primary risks that are the most likely to occur and have the biggest impact on the safety of a product, and then you develop a plan around that as to how you're going to mitigate that. In the world of food, of the FDA and the Food Safety Modernization Act, that takes the form of what's called a HARPSI plan, and in the USDA, it takes the form of a HACCP plan. And then if we look at organizations outside the US, the EU has a group that's also has some oversight onto the safety of the food supply chain. And there they have a codex of requirements, and one of which looks at food hygiene and includes water activity as a way to assure that microbial growth can't happen on products. In the UN and Food and Ag Organization, water activity is also identified there as a method for food preservation by lowering the water activity. A rather recent development is in the realm of cannabis and cannabis production, where the ASTM, as a standards organization, has created a standard for acceptable water activity range for cannabis, and then many states are now adopting those requirements in terms of water activity as part of their state regulations. Cannabis, of course, is somewhat unique in that it's primarily at this point regulated on a state level. So each state has its own unique set of guidelines and regulations. But with this, the publication of this ASTM standard, we are seeing that many of the states are choosing to adopt that standard as part of their regulations in terms of water activity and providing safety. On the pharma side, pharmaceuticals are released and oversights provided by, again, the FDA in the US. But for the most part, the oversight is in approval of drug release programs, and within that release program, there has to be safety built into it. How is the product's safety going to be assured from a microbial standpoint, as well as chemical and other factors? But it does have to be microbially safe. USP method 1112, and USP is the United States Pharmacopoeia, is a standards organization that provides directives on and guidance on both methods as well as general informational chapters. So USP 1112, chapter 1112 is an informational chapter that identifies water activity as a justification for reduced microbial testing. And then there's also an ISO guidance that's provided for microbial control for cosmetics, as cosmetics aren't necessarily a regulated product per se, but their microbial safety, of course, is as important since many of those are applied to the skin. And so there's some guidance provided there for making sure that there's no microbial growth and contamination in these cosmetics. And again, that comes back to water activity as a way to prevent that growth. So as you can see, water activity does play a critical role in the safety of many different types of products, and because of that known relationship, it shows itself in many different at many different places in different organizations that deal with the microbial safety of various types of products. When we talk about human and animal food and government regulations, we can we can basically, whether that's a U.S.-based program or others that are more international-based, the commonality that we're starting to see among all of these, and whether we're talking about human or pet food or animal food, is this move towards a risk-based approach. And so this is a common way of being able to deal with this. The idea here is to be able to focus in on the risks that pose the most probability, or the most likely to occur, as well as the ones that that are the most potentially dangerous or have the highest level of risk. And doing that risk assessment, the burden is actually placed on the manufacturer themselves to do that risk assessment for the particular product that they're making, and then to build a safety program based upon that identifies those risks and how those risks are going to be mitigated through process controls, and then monitoring those process controls or preventative controls. And so there's guidance that's been provided as part of the FSMA update, as well as there are guidances provided by the USDA for producing HACCP plans, other documents that exist as ways of trying to help these manufacturers to be able to build these foods or these safety programs that are built on solid science, as well as have built into them a means of being able to make sure that they work properly, that the preventative controls are in place, that corrective actions are identified if things break down, and ways that the manufacturer is going to monitor all of this food safety program. So some examples of some food safety programs are, of course, the HACCP plans that have been around for some time, HARPC plans, which are basically a modification of HACCP that fits within the food safety or the FSMA guidelines. And then we have things like the GSFI. This is the Global Safety Safe Food Initiative. And this is an organization that provides essentially third-party auditing and guidance to manufacturing companies to help them adhere to a very strict set of safety guidelines, and they assist essentially in building these safety programs, and then provide auditing for those as well to help make sure that these companies are going to pass any audit that they may face. And of course, within any of these safety programs and the guidance provided by the government in the form of various guidance, you can see an example of one as part of the FSMA guidelines that are shown here in terms of building a HARPC plan, and there you see chapter 4 that discusses preventative controls. And one of those preventative controls is water activity reduction. It's considered a critical control for mitigation of microbial risk of growth on a product after it's been manufactured. So if the product is meant to be shelf stable, which is an indication that there isn't the potential for microbial growth on the product itself when it's sold off the shelf, there's no refrigeration, no temperature control, then water activity is the justification for that, or one of the justifications. And so then within this food safety program, it needs to be identified that water activity reduction is the preventative action, or the critical control point, depending on what you're talking about. And then at a certain level that's been identified for the product. And then within that program, there needs to be some identification of how that's going to be monitored and how it's going to be verified. So you say in your food safety program or your drug release program that you're going to reduce the water activity as a preventative control. How are you going to monitor that? How are you going to verify that? And that's a critical part of any food safety program. So when we talk about monitoring and auditing, if you look in the government, the guidance provided by government regulatory bodies, they rarely will certify a specific monitoring method or a manufacturer. So the or an instrument manufacturer or a specific instrument. So the manufacturer themselves, the producer, are responsible for not only producing their food safety program, but identifying how are they going to effectively monitor these preventative actions. And they have to be able to verify that. And so it's not necessarily enough just to say again that you're going to control water activity and then you produce results if you don't have any way of being able to uh, to to show and declare the viability of those results and whether or not they're valid and whether or not they've been done in a specific way that ensures repeatability and ensures accuracy. And so it's the burden is then again on the manufacturer as to how they're going to write up their food safety program in such a way that they're able to justify what the water activity level they're using and to build into the system a way of being able to ensure that the water activity testing results that are produced on a day-to-day basis are being done in such a way that their validity can be relied upon. And one of the most effective ways to do that is to then reference in the food safety program a standard method that's being adhered to, because then that gives the indication of repeatability and indication of consistency in terms of how these test results are going to be determined, so that changes in how the test is being done aren't going to become a source of variation that could lead to false positive tests or even false negative tests. If that's done, then an auditor that's overseeing that food safety program, they only need to be able to observe then that the testing is actually being done according to that standard method. So it gives a reference point for the auditor as well to say, oh, they're using this standard method that's been established. So there's confidence in the water activity results. A secondary way to verify and ensure that validity is, of course, to check the instrumentation and make sure that it's verified and calibrated when necessary. And the guidance is to do this according to the manufacturer's instructions, and then you use reference standards. And so when an audit's being done, there's a good chance that they would request verification results that indicate that the instrument itself is working the way that it's supposed to. So that's verification results done on some sort of a reference standard. And so sorry, we're just getting a little bit of background. Apologize for that. And so those auditors will look to see if there is a record of tests being done on these reference standards, and that those tests, that those reference standards, the results on those reference standards are meeting requirements and are valid results. So between those two, and it's sort of a backup to each other, you're using a standard method and you're verifying your instrument through reference standards, is a good a way of being able to provide confidence in the results when you are facing an audit, as well as knowing and having the confidence that your results are good so that it's not going to lead to problems, because microbial failures are, of course, very, very costly. They're costly in terms of illnesses and potentially even for death, and they're also costly in terms of revenue and in dollars. So recalls themselves can be very, very costly, millions of dollars in product losses, and of course operational delays, and not to mention the cost of actually recalling the materials. When that happens, there's of course accompanied with a loss of consumer confidence, and that breakdown or that failure is then translated to other products that are made by that manufacturer under the assumption that if one's bad, then they all must be bad. So there's an overall damage to the company's reputation, and there's even possible legal ramifications, as we've seen recently, when these failures occur, and especially when the failures occur and there was the possibility or the potential to be able to stop them, and that there was that the failure to do that because of either falsifying records or knowingly putting into question the validity of testing results by trying to alternate the methods being used, or to get false records that have been sped up. So in terms of food safety concerns in the United States alone, we're looking at 152 billion in annual costs associated with foodborne illnesses, 76 million illnesses, multiple hospitalizations, and even up to 5,000 deaths annually. These numbers are for several years ago, and the hope is that through this push towards a more risk-based approach with more auditing going on, as well as with plans that are put into place that have multiple preventative actions. The hope is that those numbers will go down. But certainly we've had occurrences of failures in the past. Just a couple of examples. One of the most famous is the Peanut Corporation. They shipped peanut butter, of course, contaminated with salmonella, led to 9 deaths and 700 illnesses. The real bad thing was this was being added as an ingredient, so it was going into multiple types of products, not just simply by one brand, but multiple brands. And it ended up that there was some things that were done that were done intentionally to try and get the product to pass. As a result, there were legal ramifications because of that, and then of course a significant cost of up to $1 billion. That could have been prevented, and had there been good safety programs in place, good sanitation programs in place, and making sure that any kind of monitoring that's going on, those results are valid, and that they're reliable because they're backed up by reference to a standard method, reference to standard references that can be used. Another example is the flour recall that's happened recently. A couple of companies involved there where the flour was contaminated with E. coli. Not that it grew on it. It didn't. The organisms, the salmonella on the peanut butter and the E. coli on the flour, did not grow there. The water activity is too low on both of those to support growth. But it was contaminated with it through inoculation from an outside source. In this case, about 20,000 cases had to be recalled of this flour. And as a result of several of these occurrences where low moisture ingredients have been contaminated and been the source of contamination that's led to illnesses and recalls, there's been an effort by FSMA to introduce, as part of FSMA, to introduce guidance on pasteurization of low moisture ingredients. And that, of course, comes with its challenges. It's very difficult to pasteurize a low moisture ingredient. It's by definition, it has very low water activity, and effect as the water activity goes down, the difficulty in killing an organism increases. And so trying to get effective kills at these very low water activities that's associated with these ingredients can be very challenging, and in fact there's a nationwide effort in trying to be able to optimize how this process can be done in such a way that that limits the burden on those that are producing it, but still assures that they're sending safe product. Now, in terms of pharmaceuticals, microbial control, of course, is critical in pharmaceuticals. Things are taken orally or applied on the skin, have to be microbially safe. Here again, the practice is for companies that want to release a drug product. They have to put together a release program that identifies how it will be manufactured, what it's going to help with, what are the side effects, and how they're going to assure the microbial stability of that product so that it's not supporting growth and leading to infections. The main way of being able to do this in the past was to do a very high level of microbial challenge testing, where you basically take the product and test it to see if there's any microorganisms present. That can be quite time consuming to do that, especially when you're doing it on products whose water activity would never support microbial growth. And so USP Chapter 1112 provides the justification and rationale for reducing the frequency of that testing based upon water activity. If the product inherently, because of its water activity, can't support growth, and you have good manufacturing practices so that there's not inoculant there or present, then there's no reason to do it over time, because it's not going to support the growth. It's not going to change over time unless you've allowed for an inoculant to come in. And so that justification is provided, and as a result, we've seen an upswing of testing of water activity in the pharmaceutical industry, as well as its inclusion in newer drug release programs. As of right now, as far as the USP Chapter 1112, the recommendation there is to use a method that's within the compendium of microbiological methods, but there is a new actual method coming out from USP for water activity, USP 922 publication expected within the year. That gives additional guidance on how to conduct water activity when it comes to pharmaceutical products. So the pharmacopoeia provides guidance, the U.S. pharmacopoeia for pharmaceuticals within the U.S. industry, but some of those are adopted into other pharmacopoeias as well. But in an effort to try and harmonize those guidelines, there's something called the International Conference on Harmonization, or ICH guidelines. And this is basically trying to take and standardize the guidance that's given for producing drug release programs throughout the world. And so built into these are these decision trees that allow for somebody who's creating these plans to do sort of a yes/no question answer and then move through, and it takes you through almost like a wizard to what the endpoint is that should be included in the program. And there are several decision trees. We find water activity where it doesn't necessarily name it, but what it says is that if you can provide supporting data that there is no, that the product is inherently low enough moisture or dry enough so that it won't support microbial growth. And that all comes down to water activity. That's the only way to be able to do that. And so it ultimately means water activity in the case of these guidelines as well. So water activity is, in terms of microbial safety over time, it shows up in all kinds of different areas and really is critical to making sure that your product is going to remain safe. So these plans, these safety plans are built in many cases around this idea of water activity and the preventative control or safety that it provides. So it's critical then again to be able to make sure that those results are reliable and valid. And as we stated earlier, one of the ways to do that is to outline in the safety program that the water activity testing that's going to be used to monitor this as a preventative control will be done according to established standard methods. And so I wanted to talk just a little bit about some of those water activity standard methods. There's not a large number of them that are out there. And so let's go over each of them, a couple of them in specifics as we discuss these different methods. So that includes the AOAC method, an ISO method, ASTM standard, that compendium that was referenced earlier, and then of course coming soon, the USP Chapter 922. So if we look at the AOAC 978.18, this method was last updated in 1990, so it is a bit dated at this point. There hasn't been any kind of updates or improvements to the method since then, but it is the most common method, at least in the food industry, referenced in the US. And what's interesting about AOAC methods is that they are specific to the product. So in their description, they will actually identify a specific product the test is being run on. So in the case of this AOAC method, the strange thing is that it's actually for measuring the water activity of low acid canned vegetables, which is very interesting because there's really no reason to measure the water activity of canned vegetables. It's very high, and the safety that the preventative and action on canned vegetables, of course, is a retort that makes those safe. And so it's kind of interesting that that's where this method is focused. What ends up happening is that people use it as a reference anyway, even though they're measuring products that are not canned vegetables. And it does, within its guidelines, identify which instruments can be used based on the technologies that were available at the time. So again, outdated in comparison to what's available now, but because the electrolytic sensor was around back then, that's used within the Novacina water activity instruments provided by Neutec, it does mention that electrolytic sensor by name as being an acceptable way to measure water activity. What's also interesting is that it only lists saturated slurries as the acceptable reference standard or water activity standard. There are unsaturated salt solutions that are provided as reference standards for water activity, but specifically if you're looking at the text and the verbiage of AOAC, they list only saturated slurries as the acceptable water activity standard. So that's one method that could be referenced. It could be a better method. It would be nice to update that. There's a lot of work obviously associated with that, and ultimately to really meet the requirements, it would need to be done in according to AOAC's method of approach. Would have to be done in every possible food product that you were going to ever measure water activity in, and that seems a little bit overwhelming, I would think. So not a lot of work has been done in that area. A much newer method that's available, though, is the ISO method. This is ISO 18787. Replaces an earlier method that was published by ISO, and this version was published in 2017. The nice thing here is that this method is not specific to any kind of product. It's just a general guidance for measuring water activity on any kind of product. And in this case, it does list some specifics in terms of suggested requirements, such as temp control. So here it suggests a temperature control of plus or minus 1 degree C. So it is requiring that you use an instrument that has temperature control, and we'll talk about why that's important. But it does eliminate some types of instruments that are available in the marketplace that do not have temperature control. It also requires a resolution into the 4th digit. That doesn't mean accuracy, that means resolution. That means it shows the results in the 4th digit, but it doesn't mean it has to be accurate to the 4th digit. In fact, this method doesn't actually define a specific required accuracy. What it does define, though, is what will end the test. What is an indication of the end of the test? And so which is, in terms of water activity, that's an indication that's indicated by when you've achieved vapor equilibrium. So vapor equilibrium is required in order to determine the vapor pressure above a sample that's needed to measure water activity. Now, if you're not familiar with what water activity is, we have other webinars that have gone over that, and we'd invite you to spend some time with that. But ultimately here, what has to happen is there has to be some sort of an indication of the end of the test. And that's typically done by looking at changes in the water activity test results coming in over time. And so that may be something as simple as having 2 tests that are within, say, a certain water activity of each other. And as soon as that's achieved, then the test ends as an indication that you've achieved vapor equilibrium. The key thing here, though, is that vapor equilibrium, in terms of how long that takes, is defined by the matrix, and it's not something you can change. You can speed up artificially in any way. It takes what it takes, as dictated by the product that you're measuring. So there's no way to artificially make everything read under 5 minutes, for instance. The time that it takes to reach vapor equilibrium is defined by the matrix, not by the instrument itself. So that's really critical, and we'll talk about what can happen if you don't achieve full vapor equilibrium in just a minute. But for this ISO methodology, it specifically says that stability or end of test is determined when you have either three differences that are 0.003 or less, or that you achieve that difference for 1 minute. So those are specific requirements in terms of the stability setting. One thing that's unique about the instruments provided by Novacina is that they do provide the capability of being able to adjust that stability setting that ends the test. That means they can be sped up by making that less stringent, but also they can meet any stability requirement that may come with a standard method, including this method. In fact, it's a specific stability setting you can choose. When you choose that setting, it will show itself as ISO 18787. Another thing defined in this method is the sensor cannot be sensitive to volatiles if you're going to read volatiles. So a chilled mirror, for instance, is sensitive to volatiles, so it can. There's some things that it can't read. The electrolytic sensor is protected by filters, so it's capable of being able to read any type of volatiles. It just may need to require a use of a filter. And then it also identifies saturated salt standards as a way to verify the instruments. ASTM produced a method as well for measuring water activity in cannabis. This was published in 2018. Again, it has some specifics. Temp control is now at 0.1 for this one. Identifies a resolution, but in this case, identifies an accuracy as well. So in order to meet the requirements of the ASTM standard for measuring cannabis, the instrument does have to be accurate to plus or minus 0.005 and be able to measure cannabis products that are quite full of volatiles like terpenes that can interfere if you don't use filters or if you're trying to use alternative technologies. Now, in terms of accurate measurements, so we've identified those standards that you can use to reference as a way of being able to assure that your results are good. The other is to make sure the instrument's reading correctly and giving accurate results. And that's most important thing there is to check it against verification standards. And again, there are saturated slurries and there are unsaturated salt solutions. Another important factor is temperature, where temperature control is important because water activity is temperature dependent. And then also that there are certain things that need to be factored in when you think about sample preparation, where they can potentially impact the results if you don't handle the samples properly prior to running a test. So let's talk about some standards then. So as I mentioned earlier, saturated salt standards are what's preferred by AOAC and ISO. The nice thing about these, any salt at saturation has a specific water activity defined by thermodynamics. So if you know the salt and it's in a slurry form, you know the water activity. So you can check any instrument with these standards and make sure it's reading correctly. Nice thing is they're reusable for up to 3 years as long as you keep them stored in the container they come in. So it's not a consumable. They will change with temperature, and there's a guidance provided with them to show you what that value would be if you were to read at some temperature other than, say, 25°C. And a key thing here then is that because these are reusable and not a consumable, they can actually result in a lot of cost savings, especially if references are being used at multiple locations for a company. The price of those consumables for a given year can be substantial into the thousands and thousands of dollars. So this is an advantage of being able to have access to saturated salt standards, which is what Novacina provides and what Neutec provides in behalf of Novacina in the US. As I mentioned, temperature does have an impact on water activity. Water activity changes with temperature. Because of that, all water activity results need to have a temperature. Without a temperature, if you just show water activity on your records, it's meaningless because there's no way to repeat it because you don't know what temperature it was done at. So in general, as temperature increases, so will water activity, but that's not always the case. It's very product specific, and some products are not very sensitive to changes in temperature in terms of their water activity. So it's something to be aware of. Because of that impact of temperature, you should use a water activity instrument that's temperature controlled. Otherwise, the instrument's just going up and down with fluctuations in room ambient temperature. So sometime in the year it could be at 22, another time it could be at 27, and it makes it very difficult to have reliability over time because you're doing comparisons at different temperatures. So it's critical that you use a temperature controlled instrument, and you really shouldn't, the test itself should not be started, and this is usually a user setting on the instruments, but you shouldn't start the test until the sample's within 1°C of the instrument, because if it's far away from the instrument, then it's changing its temperature. It's trying to thermally equilibrate. And as it does that, you can have changes in water activity. So it will extend the test time, or if it manages to finish early, it could be giving you incorrect results. And then the system must be able to compensate for any temperature difference between the sample and the sensor, because you're measuring equilibrium relative humidity at the sensor itself, but the sample is the temperature is where you need to know water activity. So in order for those to meet, either you have to have complete equilibrium between them, or you have to monitor the temperature of each of them separately so that you can account for any differences in temperature in the final calculation. Now, in terms of sample preparation, water activity is an intensive property, so it doesn't matter how much material you put in. Weight of material is not critical. It's more about volume, because you do need to have enough sample there so that the water and the relative humidity in the headspace will come to equilibrium with the sample, and so the sample's dictating that. So you can't just put in one little tiny, say, vegetable seed and try to measure its water activity. You have to have enough there, and that's typically to cover the bottom of the cup is enough. And that doesn't mean there can't be some showing through or spaces. It just means that's a general guideline. And that usually ends up being about quarter to a half full. You don't want to overfill the cups because that can lead to contamination. For most things, that's typically in terms of volume about 5 to 10 mils of sample. Now, in terms of how you present that sample, whether you crush it or you leave it intact, that can have some impact as well. In general, you want to be consistent in how you do that, and increasing surface area tends to help in repeatability of tests. So things that are solid and have coatings, you want to crush or grind those to get a higher level of surface area. Another important thing is that you want to prevent moisture loss on these samples. So any amount of time that a sample is sitting exposed to ambient room, it's being influenced by the relative humidity of the room. Relative humidity, water activity are essentially the same thing. So if you have a low water activity product and you have, or a more likely high water activity product, and you're exposing it to a room with low humidity, the sample is losing water and its water activity is going down as a consequence. And so you could be getting falsely low water activity readings that would then indicate that maybe the product's safe when it's not. So it's really important to isolate the sample from the room. So that means using the lids as short-term storage, and also if you're going to store for any length of time between sampling and testing, then you need to put them in a sealed, moisture-tight container. Glass is the best. Whirlpacks are not. They do not seal up, so they're not an effective way of storing samples prior to testing. Now, in terms of fast and repeatable results, the ultimate test is always defined as being the one that's it's fast, it's accurate, and it's repeatable, and everybody wants all of those things. And in a lot of cases, that's very difficult. If you want speed, you got to, in most cases, you're going to sacrifice some accuracy and repeatability, and so that's important to understand when you're trying to produce results that are going to be held up against audits and to make sure that your product's safe. Are you willing to sacrifice the validity of sample results in the name of trying to get those test results faster? And obviously, the faster the better. That's certainly true. But with what kind of cost? And within the as far as what can help with that speed, I mentioned earlier, optimizing that sample prep can really help with that. And we've done a webinar that deals with water activity measurement and talks about sample preparation and some of the things to consider. And I would encourage you to reference that if you haven't, if you didn't attend that. It provides additional information about exactly what different sample preps can do to the sample, but mainly here you want to increase, as I said, surface area with minimal damage. The higher the surface area, the faster equilibration process can occur. So that can speed up that vapor equilibration process I mentioned earlier. It's still dictated by the matrix, but you're taking away some physical barriers to that, and that can speed it up. But again, there's no way to artificially speed up the vapor equilibration process itself of a particular type of sample in a particular form to try and make it read faster. A vapor equilibrium takes what it takes. And the only way that you can then adjust that really is by adjusting what you're going to use to determine when the vapor equilibrium has been achieved. And so adjusting the stability settings can speed up the test, but at what cost? Within the Novacina instruments provided by Neutec, they do have different settings. So slow is the most stringent. It requires that you get no difference greater than 0.001 water activity over the space of 6 minutes. So it's incredibly strict. That means 6 minutes is the minimum time of the test. And so by doing that, you assure that you've achieved vapor equilibrium and that you're not going to have any inconsistencies that result from ending the test too quick. Now, there are settings that will do it faster because they're less stringent. Average is 4 minutes, fast is 2 minutes. Manual, you can set to any stability time. So it is possible that you could speed up the test, but at what cost again? So you may not have achieved true vapor equilibrium, but it does give you at least the capability of doing that. Some other systems, there's no ability to be able to change those settings. They are what they are. And if they're structured in such a way that they can give an indication of the end of the test before true vapor equilibrium has been achieved, that can be dangerous. So for instance, if the test requires only a difference being achieved one time in order to indicate the end of the test, you might get results in under 5 minutes, but is that the true vapor equilibrium result? And that's what's the question. And by not being able to change that setting, it's virtually impossible to know if you're getting false readings. So for instance, if that were the case, and after a couple of minutes of reading, under 5 minutes of reading, you get a result that's water activity 0.84, you pass it because your cutoff level is say 8.6. If you were to let that test continue, because it hadn't actually achieved vapor equilibrium, it just achieved the requirement for the end of the test, you might find out that it continues to go up and that the actual water activity when you've achieved vapor equilibrium is 0.87. That now fails. So under this scenario, a product that shouldn't have passed has been passed. And that could have the potential then for microbial contamination. Or if it's caught by an auditor, you could have problems because you were trying to get fast readings. So the take-home message here is to not sacrifice the validity of results for time. You try to maximize the efficiency of your timing, but to make sure that you're still getting viable results. And this is especially true if you were to try and, say, do a prediction based on the initial data where you extrapolate, and extrapolation is always dangerous. Interpolation is much better than extrapolation, but you then extrapolate of what the final result will be, and you're going to provide that as your actual release water activity. That can be very, very dangerous situation where if that's not, the assumptions that are made for that prediction are not met, you can run into a lot of trouble. So in terms of water activity instrumentation, I just wanted to quickly give you an overview of what's provided by Neutec. Again, the producer here is Novacina, a Swiss company that's been producing for many, many years. Neutec is a great distributor for them in the US. They have the capability of servicing all of these instruments, taking care of them, providing application support through my efforts. So it's a real powerful team that's here to make sure, and our focus along with Novacina is on being able to provide good, reliable results. We don't ever want to put you as a customer in any kind of position where you could have the potential to have problems because of your water activity results, whether that's failing an audit or it's worse, it's resulting in a recall. So we're here, and that's what we're dedicated to, is making sure that you get the best results possible. We don't then focus on trying to artificially speed up test results. We try to be able to provide true vapor equilibrium results that are going to give you reliable results that can be counted on. And then in addition to that, we're dedicated fully to the science of water activity and being able to provide you with any kind of information you might need to know on water activity. I've spent my entire career on this, and so I have lots of experience with all kinds of different instruments as well as applications for water activity. Keeping in mind here, one of the main things is that the temperature control we talked about. The Neo and the Touch both have it and will meet those requirements from a standard method. The lower versions are lower cost, but lower cost isn't always the best option because you do sacrifice that temperature control, and that may make it so you don't meet standard methods. So it's something to really consider when you're thinking about what water activity instrument to use. So in summary, governmental food safety programs, they place the burden on the manufacturer to produce a safe product. So those programs need to identify the greatest risks and then establish preventative controls for those risks. And in order to make sure those preventative controls work, there need to be effective monitoring tools in place, like water activity, that assures that lowering the water activity as a preventative control, that's being met, and that the results are valid and that the results are reliable. And so to be able to do that, one of the most effective ways, twofold: conform to standard methods and identify that method that you're using, and then verify with acceptable water activity standards. And as we said, that's those saturated slurries. And then make sure that you're not sacrificing true vapor equilibrium for your water activity tests in the name of speed. Make sure that you optimize the test time, but that you're getting true vapor equilibrium results that can make sure that your test results are reliable and can be counted on. And again, the purpose here is to make sure that there's never a situation you could where those results could be sacrificed, and the validity of those could be sacrificed. So we want to continue in terms of Neutec to be your source for water activity information and instruments in the US. We're happy to provide any kind of assistance that you might need, both from a instrumentation standpoint as well as from an application standpoint. I'm available through email or over the phone to be able to answer any questions you may have. We even offer consulting services if you want to get to some in-depth levels in terms of water activity. We do provide consulting services where we can assist you with specifics on water activity applications. So that I think we have a little bit of time left for questions.
Thank you, Brady. We do have a little bit more time. Our first question: which type of sample poses the greatest challenges for obtaining reliable water activity results?
Yeah, so as we briefly mentioned, there's some types of samples need some very specific handling requirements, as well as how the sample's prepared itself. And again, we go into more detail on that on an additional webinar. But really, what determines that is samples that tend to be moisture sensitive, and by that I mean that they don't really have very much moisture in them. But if there's any kind of moisture added, it causes the water activity to jump drastically. And some examples are things like fats, high fat material. You might think, well, it's mostly fat, so there's no water here, so my water activity should be very low. But in reality, if there's any kind, even maybe a less than 1% change in moisture can result in huge jumps in water activity, say from 0.2 all the way to 0.7. Just by that little minuscule amount of water, because the water comes in and doesn't have anything to interact with, and so its energy remains high because there's no transfer of energy due to those types of binding or interactions, because there's nothing there for water to interact with. Similar on crystalline materials, you'll see this as well. If you try to measure crystalline materials, they're very sensitive to the room humidity. If these types of samples are exposed for any amount of time, a short amount of time to the room, they will change to the room's humidity. That's what their water activity will be, because that changes so quickly, and it doesn't take very much adsorption or desorption of water in order for their water activities to change. So those can be troubling in terms of getting repeatable results if what you're finding is that they're just going to whatever room humidity is. So they have to be handled very carefully and minimize, and we're talking seconds of time exposed to the room as you're placing them in the instrument to run tests.
Brady, we have time for maybe one last question. Are there recommendations on which calibration standards should be performed as part of daily verification? Should you run standards based on what AW level you think is in your product or similar product? For example, bread, bakery versus jerky.
Yeah, so great question. As far as verification goes, and that's one advantage of the electrolytic sensor, because it's so stable and protected against contamination, It doesn't require as frequent a verification. So you can set up your verification plans based on, again, when you set those up based on manufacturer recommendations. The recommendation on the electrolytic sensor is that you only really need to verify it even weekly. But you can, of course, set it up daily and depending on what you want to do in your program. But when you do a verification, it's always good practice to essentially bookend, which means that you do a water activity standard that's below and above the region that you assume that your product's going to be. So if everything you read is in the 0.7 to 0.8 range, then you would use a verification standard, say at 0.75, and a verification standard at, say, 0.84, and that would bookend those. And so that you know that it's reading correct below and correct above, so there's no chance of any kind of slope difference that could lead to differences in the values over that water activity range. If you read, I'll cover the entire range, then you might want to add an additional standard and do one sort of low, middle, and high as a way of doing that. And of course, the saturated salt slurries that come with from Neutec, when you get an instrument, there'll be a range of them provided to you. You may not use all of those. They're there so that you can adjust the calibration if needed across the entire water activity range, but there may be some that you never actually utilize. And that just means that when you need to replace them, when the shelf life ends, then you may only need to replace one or two or three of the standards, depending on how you set up your verification process. But that's in general the recommendation. As long as those verification runs that you're running on the standards are within the tolerance that's required for the instrument, there's really no reason to ever adjust the calibration. That only needs to be adjusted if they aren't reading those verification standards within the tolerance levels of the instrument.
Thank you so much, Brady. So much information. Before we wrap up, please, everyone, just check the chat box for the survey link. We really want your feedback so that we can present you with more information that you're interested in. Thank you again for joining us. Thank you, Brady. We hope to see you in future webinars, and take care, stay healthy, and stay safe.